In Western Australia, when constructing groundwater drains, as part of a salinity mitigation strategy, landholders have not always been mindful of the unique characteristics of a site and adapted their design and construction techniques accordingly. To help address this and provide a template for better practice methods, a groundwater drain demonstration site has been built at the Katanning Research Station. Using the latest design and construction techniques, the site incorporates a mix of salinity mitigation methods tailored to suit the physical landscape of KRS, including revegetation and surface water control measures. In this video, we will go through the methods employed at the site, including the importance of planning and understanding the physical details of a site before any earthworks take place. The department's John Firth has been advising landholders about groundwater drains for many years, ensuring their designs are up to standard and comply with state regulations. One of the first things he talks about is conducting site assessments prior to any earthworks. These initial investigations will give a good indication on how effective a drain will be, with one of the best tools for doing this being a test pit.
When digging a test pit, what you're trying to do is a number of things. First of all, you're trying to find out if there's any water there. What is the depth of the groundwater? We're also trying to find out at what depth is the groundwater flowing into the test pit and what volume of water is coming into that test pit. So we want to know the discharge rate of that soil. By digging test pits, you also get an understanding of the soils you're encountering on that particular location and at what depth they are in the landscape. At this time, I also suggest to landholders that if possible they put in some sort of monitoring bores or observation wells to see where the actual water table is or measure the rise of the water table at different times of the year. What we've got installed here is a row of piezometers and observation wells. These were installed prior to the drain going in so we get some good baseline measurements. And here we have a shallow piezometer. This goes down to about 3 metres and the deeper one over there normally goes down to around 10 metres. So we can see the effects of the drain after the drain's been installed. Surface and groundwater structures are quite different. And if you pull them down to their basic context, surface water earthworks deal with water that flows across the ground. So we're dealing with water that occurs after natural rainfall events. There's a number of reasons why we keep the surface and groundwater separate. First of all, the surface water is fresher. Groundwater drains are generally more saline. We don't want the higher volumes of fresh water flowing into the drains and causing structural failure of drains or erosion or silts or sediments to transfer off-site. And the other thing is we need to make certain we have full control or managing surface groundwater flows. This is why we'll actually place the groundwater drain alongside a waterway, not in the waterway. And we used levee banks on both sides of the drain to exclude the surface water, which is very important. The surface water now is flowing down along the levees on the groundwater drain and managed in a very safe way, and we actually allow that water to discharge into the existing dams on the property to collect any sediments that may be flowing down the drain. This was a saline dam, and what we've done now, we've turned it into a detention dam and a silt pit at the same time. We use it as a silt pit to collect any surface water flow sediments that, like this here, flowing into the dam, or from any sediments coming out of the drain itself. It's used as a detention dam because in a flood situation we may have excess surface water flowing into the dam. The dam acts as a short-term storage, and the pipe over there will actually take the water out of the dam back to its original level. As a general rule when constructing groundwater drains, we start at the bottom where the drain is going to discharge, and then we continue upslope from ground level till we reach the nominated depth of the drain. And if the land slope allows, we can then maintain that depth. When it comes to the discharge flow from groundwater drains, a lot of people have the perception that a lot of water is going to flow out of the drains. In reality, because the soils encountered don't like to yield very much water, the flow of water out of a drain can be quite low, it can be quite shallow, and it can appear as just as a gentle trickle flowing down the drain. One of the critical aspects in drain design is the shape of the drain. In other words, what is the slope of the side batters? What is the width of the drain floor? And how deep is that drain? When it comes to the side slopes, they can vary considerably depending on your soil types. Some soil types are much stronger and more stable, so your sides can be more vertical. They may be up to something like about 60 or 75 degrees. When you're talking in less stable soils, we like those slopes to head back towards about 45 degrees. In very poor soils, the slope of the side batter may be extremely low and go down to as low as 15 degrees. Having said this, you can move another couple of metres along a groundwater drain and you encounter a different soil type again. At this site you get a good idea of the angle of the batters, and the only way we could get this angle was using a swivel bucket. So we adjusted the angle of the bank because we had a swivel bucket. And here we've actually laid them down a little bit because some of the soil types here aren't very stable. When constructing groundwater drains, it's very important that the person constructing the groundwater drains fully understands the concept of the drains, the design of the drains, and what you're trying to achieve. So at the very start of a person digging a drain, it's important that you're there to ensure that they follow the design criteria. At the Katanning Research Station, the operator we employed was fully supervised at the start of digging the drains and was basically trained in the style that we wanted the drains to be dug. Also, by having that close communication with the operator, he was able to point out a few other little things in order to help him to do his job much more easily. And through that working together, we actually came up with a drain that was actually better than the original design.
Biodiversity restoration specialist Keith Smith took the reins for the revegetation side of the project, and he uses a system he has honed over the 30-odd years he has been working with native plants. This system uses a mix of native seed and tube stock that's not only suited to the conditions of each site, but one that ensures each project has the best chance of success.
When I'm looking to establish a new site, I look at the reference sites that are near it, so the natural bush close to where we are, and look at the species, and we try and mimic that with our restoration, because the more species that we can get into our mix to build up the diversity, the more functionality that will create and resilience into the future with that restoration. And this is what we did at the Katanning Research Station. We did an on-ground site assessment. So we walked onto the ground, kicked the dirt, so to speak. We did dig test pit holes to look at the soil profile. And we also noticed that there was barley grass scald areas, which is a good indication that there's a salt presence in that area. So we could have addressed the waterlogging and salinity issues with plants alone without the drainage works, but we wanted to showcase both the drainage system and the importance of a really good connected species mix supporting that drain network. Because we were afforded 12 months lead time in preparation to the actual restoration, it gave us time to go and collect Indigenous species local to that area that were going to be adapted to this site. So we've had around 50 species in this mix. The bulk of the seed mix was understory species and shrubs put through in the direct seeding mechanism, and the tree component was actually planted as tube stock. They were grown by the local Katanning nursery using seed collected that 12 months prior from local provenance. Being an ex-agricultural site, this area at the Katanning Research Station had significant weed burdens, and it was important to address this. So we sprayed 12 months prior to the seeding to get a really good weed kill and stop a weed burden developing in the soil. And we also sprayed a month out from planting just to help with reducing that competition for the emerging seedlings. So monitoring is a really important part of the process after revegetation, keeping an eye on things that like to eat your emerging seedlings, like spring beetles, and just the same, keeping livestock out. Livestock can trample the emerging seedlings and actually undo a lot of really good work. So it's important to have good fencing around your restoration if a project is to succeed.
And monitoring these fences to ensure they are protecting the plants and keeping the livestock out of the drain itself needs to be conducted regularly. As does monitoring the groundwater salinity levels and flow rates to see how effective the drains are and the changes that occur over time. But it's getting it right in the beginning that makes a big difference.
When constructing groundwater drains, if done very poorly, in a sense of it's not what we call better practice, you'll find that drain will look quite different in 10 years' time. There'll be a number of issues associated with that drain, and that drain may need maintenance several times over that period of time, whereas a well-constructed drain will require less maintenance or no maintenance in the same period of time.
When considering groundwater drainage as part of a salinity mitigation system, landholders and their contractors are strongly encouraged to visit the KRS site. Being able to walk around the site and experience firsthand the mix of salinity mitigation options that have been showcased, it's hoped that landholders can come away and make a more informed decision before installing a groundwater drain.